Hello students. So today we will do thermochemistry question part 1. So let us start our today's session. Today so our questions number will be 1 to 7. So we'll be basically practicing question from 1 to 7. For each question you will be given 10 seconds to solve them, and during I would suggest you that during the time of question dictation, means I will dictate this question also, I would suggest you that you should start doing the question. That would give you more time. Okay, so with this, let us start out today's question session. Disclaimer: the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So the first question for today. So delta H naught F of NO2 is equals to 33.84 kilojoule per mole, and delta H naught F of N2O4 is equals to 9.66 kilojoule per mole. Hence dimerization of NO2 forming N2O4 is, your options are A endothermic, B isothermic, C exothermic, D isochoric. So the hint for this question would be that you should first write the equation and then try to solve the question. Means the for the dimerization of NO2. Okay. So your 10 seconds to solve this question starts now. Okay. Let us see the solution. So the question was saying that you have to find what dimerization means. Hence dimerization of NO2 from N2O4 is what means the nature of this reaction. So we have this thing which is formation, means enthalpy change, standard enthalpy change for formation of NO2 and standard enthalpy change for formation of N2O4. We have this thing. So how we'll find it? Now for those who have solved, the correct answer is C. Okay, the correct answer is C. So this is the explanation for the following. So this is the equation we have. So we are moving from NO2 to N2O4. Now we have balanced the equation also. This is very important. And for the delta H naught means for the reaction will be what? It will be product minus reactant. Now since your enthalpy is a extensive property, right? We know enthalpy is an extensive property, and this value which is given here for NO2, it is given for 1 mole, but in the equation the stoichiometric coefficient for NO2 is 2. That means 2 moles of NO2 is being used. So accordingly we will multiply the value with 2. So delta H naught of means standard enthalpy of formation of N2O4 minus 2 multiplied by standard enthalpy of formation of NO2. So keeping the values 9.66 minus 2 into 33.84. Now remember that all of these are in kilojoule per mole, so the value will also come for the reaction as kilojoule per mole. So that is equals to minus 58.02 kilojoule. Now here you will ask that why it is written per mole. Okay, why it is not written here per mole? So basically for NO2 we have multiplied with number of moles which is 1, so that cancels out the mole and per mole thing. And similarly the number of moles for N2O4 is 1, so if you multiply it with 1, okay, if you multiply it with 1, then you will again get what? You will again get this thing, right? Means cancelling of the per mole thing. Okay, so on solving it we'll get it as minus 58.02 kilojoule. Now next thing, so we have to find the nature of the reaction. Since this delta H naught is negative, therefore the reaction is what? The reaction is exothermic, and your answer is C. Next question. Question number 2. In the reaction, your Y is moving to Z, and for that your delta H is given as plus 100 kilocalorie per mole. And for the reaction Z to X, your delta H is given as minus 80 kilocalorie per mole. And for Y to X, your delta H is given as 20 kilocalorie per mole. Now what we have to do, we have to rank the enthalpies of formation of X, Y, Z in the order of the increasing order. So your options are Y, X, Z. So all of these are in increasing order. Then we have B, Y, Z, X. Then we have C, X, Z, Y, and D, X, Y, Z. How we'll solve it? So the hint for this question would be that your enthalpy change is a what? It is a state function, right? It is a state function, and the enthalpy change for a reaction is equals to the enthalpy change of for formation of enthalpy change of formation for product minus enthalpy change of formation for reactant. Okay, use these two concepts and you will find this question very easy to solve. So your 10 seconds to solve this question starts now. So moving on to the solution part. So how we'll solve it? Let's see. So first we have to find y, this enthalpy of formation for y, for z and for x. So we will use these three equations to find the value of these three variables. Okay. So for those who have solved, the correct answer is A. Now we know that the delta H reaction is equals to summation of enthalpy of formation of product and minus summation of enthalpy of reactant. So I have told you to use this formula. So if I want to write for your what? If I want to write for your y to z, then how will write? So since we are moving from y to z, so z is the product. So enthalpy of formation of product of that is z, and enthalpy of minus enthalpy of formation of y. So this value is equals to 100 kilocalorie per mole. Okay. Now the next is what? Next is given for z to x. So accordingly, we will write here for z to x. So x means formation of x minus formation of z, that is minus 80 kilocalorie per mole. Now in this equation we can see that upon subtracting these things, means the formation of y from z gives us a positive value. What does this mean? This means that your y is smaller than z, then only this value is positive. Okay, so we have written it simply that delta H formation for z is greater than y. So this is deduced from this equation. Now from this equation it is very clear that z is greater than x. Okay, so z is greater than x. Now if z is greater than y and z is greater than x, now you have to find the comparison between x and y. For that we have the third equation which says that your delta H is 20 for y moving to x, means your your x is greater than y. Okay, your x is greater than y. How it is? Again, just write the equation. That means if you write this for this thing, then how will write it? That delta H reaction is equals to delta H formation of the product, which is x. So delta H formation of x minus delta H formation of y. So if this thing is equals to 20, that means your x formation is greater than y formation, and hence this series is obtained. Now we have this thing. So x is the greater, z is the greatest one. So z is greater than x and y both, and between x and y, x is greater. So the series will be z x y. Okay, so z will be the greatest one, then x will be the smaller, and y will be the smallest one. So overall order will look like this, because we have to write it in the ascending order from small to the large one. Okay, so this is for question number 2. Now moving on to the next question. Question number 3. So in question number 3 we have 21 gram of Fe combined with S evolving 3.77 kilojoule. The heat of formation of FeS in kilojoule per mole is, your options are A 1.79, B minus 100.5, C minus 3.77, and D none of these. So the hint for this question would be that, so basically here it is being said that 2.1 F combined with S forming 3.77 kilojoule, and the heat of formation is for FeS is to be found. So very easy question. How will solve it? So for that you should remember that what is the heat of formation and what is so basically if you remember, the heat of formation is what? It is the amount of say heat of formation is the amount of heat released when the thing which is here is formed from its constituent elements in the standard state. So if you remember this definition, then you can easily find your answer. Now you have 10 seconds to solve this question. Your time starts now. Okay, let us see how we can solve it. So for those who have solved, the correct answer is B. So it is written that when 2.1 gram combined with S, heat evolved is 3.77. Very correct. When 56 gram involved with S, then heat evolved is how much? 3.77 divided by 2.1 multiplied by 56. This thing is asked na. You have to calculate the heat of formation for 1 mole. So basically for 2.1 mole it was already given, and you have to find it for 1 mole. So so how we'll find it? So first of all, for 2.1 gram, if it is this amount, that means that for 1 gram it will be what? It will be 3.77 by 2.1, and in 1 mole the FES mass is 56. Therefore for 56 grams it is multiplied by 56. Okay, or else you can do it in this way also, that delta H is given for how much? For 2.1 gram. So we calculate the number of moles in 2.1 gram. So in 2.1 gram, how many moles will be there? 2.1 by 56. Therefore, what will be the delta H formation? Means molar heat of molar enthalpy of formation. It will be the enthalpy change divided by the number of moles, and that would give you 100.5. Okay, so this value will be in kilojoule per mole. Okay, so now it is being in negative since the heat is evolved in the formation of FES, so the heat of formation will be negative of 100.5 kilojoule per mole. Okay, so in this way you will solve this question number 3. Now moving on to the next question. Question number 4. Which of the following is our endothermic process? Endothermic process means in which the heat is being utilized. Number 1, combustion of methane. 2, decomposition of water. 3, dehydrogenation of ethane to ethyl. 4, conversion of graphite to diamond. Okay, so you have to find that which of this endothermic means which needs heat for the reaction to move forward. Now your options are A 1 and 2, B 2 and 3, C 3 and 4, and D 2, 3 and 4. So you have 10 seconds to solve this question. Your time starts now. So let us move to the solution part. So this was your question. So for endothermic, it is very easy to see here that this is decomposition of water. Combustion of methane initially requires heat. Okay, initially requires heat, and the product that is formed is what? The product that is formed is CO2 and H2O. For decomposition of water, it will be H2 plus O2. For dehydrogenation of ethane to ethylene, so what we have to do? We have to remove hydrogen. And for conversion of graphite to diamond is also an endothermic process. So this is an endothermic process. Let us see all of the three that is remaining. So the correct answer is D. So in this case, your heat will be involved. We have seen that. In the second thing, heat will be given. Okay, because we need energy to decompose it. In the third thing also, what we do? But we have to supply heat to dehydrogenate it. And in the fourth one also, we have to supply heat. So we can easily see that all of these three are what? Requiring heat for the reaction to go forward, or they are being catalyzed by the presence of heat or energy. So we can say easily that these three are the endothermic reaction. So 2, 3 and 4 are the endothermic reaction. Okay. So this is the correct answer, which is D. Now moving on to the next question. Question number 5. The delta H, the standard enthalpy of formation for CO2 gaseous CO H2O are minus 393.5, minus 110.5, and minus 241.8 kilojoule per mole respectively. The standard enthalpy change in kilojoule for the reaction is The reaction is given as CO2 gaseous plus H2 gaseous gives us CO gaseous plus H2 gaseous. Is options are 5 to 4.1, B 41.2, C minus 262.5, and D minus 41.2. So how will solve this question? So you have to find it for this equation, right? So you will simply use the equation which is delta H reaction is given as delta H formation of the product minus delta H formation of the reactant. But remember to multiply by the stoichiometric coefficient. Okay. So your 10 seconds to solve this question starts now. Okay. Okay. So let us see the solution. So for each species we are given, right? So we don't have to worry about this. So one will ask that why it is not given for H2 gaseous. So the answer would be, since this is in the standard state, right? It is very clear that H2 is in the gaseous state, so it is the standard state of the hydrogen gas. And for the standard state, we already know that the enthalpy of formation is what? Standard enthalpy of formation is 0. Therefore, we will take the value of formation of hydrogen as 0, and and rest of the values are given. So for those who have solved, the correct answer is B. How will write it? So this is the equation. So C plus O2 is giving us CO2. This thing is given. C plus half O2 CO is also given. H2 plus half O2 is giving us H2O. This thing is also given. Okay, these three equations are given. And since it's in enthalpy of formation, standard enthalpy of formation, so we are keeping each of the reactants in their standard state. And then the value is coming out to be the given one. Okay. Now, further, we have to add this equation such that we get this equation. So we are adding 2 and 3 and subtracting 1. Hence, this is the equation that we get. So for that, we simply apply this thing on the enthalpy part also. Okay. So if you apply this in enthalpy part, you will get it as 41.2 kilojoule. So this is having 1 mole, so you don't need to multiply it with anything. Similarly, this is 1 mole, this is 1 mole, and this is also 1 mole. So it is indirectly using this formula, which is product minus reactant. You can use this formula, is also very easy to solve rather than writing these three individually. And at the same time, the enthalpy of formation for CO is taken as 0. Clear? Okay. So in this way, you will solve the question number 5. So moving on to the next question. Question number 6. Consider the following. C plus O2 is giving us CO2. Okay. Delta H for this reaction is X, means enthalpy of reaction is given as X. Then CO plus half O2 is given as CO2, and the enthalpy of this reaction is given Y. Now, what we have to do? We have to find the heat of formation for CO. Okay. Options are X minus Y, B Y minus 2X, C X plus Y, and D 2X minus Y. How will solve this question? So first thing you should remember is that your delta H is an extensive and extensive property. So it is having an additive property. You can add or subtract it. Now we have seen this multiple times, so I'm reminding you that why is it possible? Because it is an extensive property. If it is not an extensive property, then this would not have been possible. Now, second thing you should notice is that what we have to do in this question. So you have to rearrange this question such that you get the heat of formation of CO, and CO is formed from which? It will be formed from carbon and oxygen only. Okay. So accordingly, you will rearrange this thing, and you will get the heat of formation for CO. So try to get first try to write the equation for formation of CO, and then try to get it from these two equations. So your 10 seconds to solve this question starts now. Okay, let us see the solution, how I will solve it. So value for the reaction of these two are given, and we have to find it for the third. For those who have solved, the correct answer is A. Now this equation was the first equation. So we were, this is what, if I ask you what it is, so it is the enthalpy of say standard enthalpy of formation for CO2, because the constituent elements are in the standard state. And this is what, this is your for it is not a standard one because the CO is not written in standard state. Therefore this one we cannot consider the standard enthalpy of formation for CO2. So this is the one. But what we need is that we need this CO2 can be cancelled out, and this CO on that side, on the RHS side. So what we will do, we'll subtract x minus y. When we subtract x minus y, the CO2 and CO2 will get cancelled out, and CO will go on that side. Okay, accordingly we'll subtract O and minus half, and then you will get your answer. The same thing has been done here. So see, C plus half O2 is been written here. Okay, because O2 minus half O2 gives us half O2, and CO is going on that side of due to subtraction, and CO2 is getting cancelled out. So therefore delta H is equals to x minus y. So this is the correct answer, which is A. Moving on to the next question. Question number 7. On the basis of the thermochemical data, where delta H formation for aqueous is 0 and H2O is giving us H plus aqueous and OH minus aqueous, and the delta H for this reaction is 57.32 kilojoule. Similarly, where H2 plus half O2 is giving us H2O liquid, where delta H naught is minus 286.20 kilojoule. Now, the value of enthalpy of formation of OH minus ion at 27 degrees Celsius is, your options are A 22.8 kilojoule, B 228.88 kilojoule plus 228.88 kilojoule, and C and D minus 343.52 kilojoule. So these are your four options, right? So what will be the key point for this question? So in this question, what you have to find? You have to find the formation of OH minus. Now, what are the standard things that can be used to form OH minus? First, you have to recognize them, and then you have to write the equation for the enthalpy standard equation for the formation of OH minus. After that, you will utilize these two equations accordingly, so that you can get your final answer. Okay, so this is the thing. So you have 10 seconds to solve this question. Your time starts now. Okay, let us see the solution. So again, the question is same. What you have to find? You have to find the enthalpy of formation of OH minus and the dissociation of water, and the standard enthalpy of, the standard in the formation of energy, means the standard enthalpy of formation of water is already given. And third thing is your formation of H plus is given, for aqueous H plus is given 0. For those who have solved, the correct answer is B. Now, considering the heat of formation of H2O, I have already told you this is nothing but an enthalpy of formation of H2O. That is standard enthalpy. So this is given as minus 286.20 kilojoule. So we have written it in this form, shorthand form. Now considering the ionization of water, so of course this is what, nothing but an ionization of water. Now we can write that delta H naught for the reaction is what? So if you want to write for this reaction, what is delta H naught for reaction? So delta H naught for formation of H plus plus delta H naught formation of OH minus. If you just add both of this and subtract the delta H formation of H2O, what you will get? You will get the delta H reaction. Now we know this thing, that is delta H formation of water, and we know that this, for this the value is 0, and delta H reaction is also given, which is 557.23 kilojoule. Now you put this thing here and you get your delta H naught formation. See, it is written 0, it is minus 286.20, which we have been given, and this is 57.32 kilojoule, which is also given. So that will give you the formation of OH minus, and that is minus 228.88 kilojoule as your correct answer. So this is your correct answer. So this was all for today's question session. Thank you.